Hey there, class. We're here today. We're going to look at adding vectors together, and this is going to be by doing graphical means. So we're not really worried too much about the mathematics of this. We're really trying to more get on the conceptual level. If you want to learn a little bit more about the conceptual level from the very beginning, I do have a video about that, and you can certainly check that out as well. But let me scroll down here to where we have our example set up. And we're going to scroll out just a little bit. So the vectors that we're going to look at here is we're going to take the vectors A and the vectors B, and we're going to add them together to get some kind of addition. The sum of two vectors or more vectors is something called the resultant. So we're looking for the resultant. So our vector in the end that we're going to get is something called the resultant, and I just use an R for that. So here we go, 12 meters at 40 degrees north of east, and 14 meters at 20 degrees east of south. And these two are the ones that we're going to take a look at here. So let me scroll out so I get to my place where I'm going to draw this. And let's see if we can get everything on the screen there. All right. Now, when we're doing this by graphical means, drawing this to scale is of the utmost critical importance. Now, of course, in the end, when we really do this, for real, we're going to be doing everything math, and the size and scale won't really matter all that much. But what I'm going to do here is I'm going to use a ruler, and you'll notice here that 40 degrees north of east is going to be this angle in here. Again, if you need a little bit more help with that, I do have a video about that as well. But I am going to set this up right here, and that's set up at the 40 degrees north of east. Let me get my blue pen. And we're going to go 12 meters. We're going to pretend that each one of these lines on here is 1 meter. So we're going to go, here's 8, there's 10, and there's 12 meters. So that's our vector. This is our vector A right here. Now, one mistake I see a lot of students make is when they draw that second vector, they forget that north is still towards the top of the page. So I like to sometimes redraw myself a compass here, or some kind of axes to just kind of go with. This isn't a new origin or anything. It's just simply something to kind of guide on. And in this case, I'm going to be going 20 degrees east of south. So here's the south, and this is going to the east of it. So the vector is going to be in this general direction. You'll notice my ruler here, of course, is measured at 70 degrees, and this is measured from the horizontal, but certainly that means this angle right in here is going to add up to be, the 70 plus the 20 that I'm supposed to have is going to give me the 90. And that, of course, that would be the angle between the south and the east. So I'm going to go 14 meters, and again, because I'm doing this to scale as best as possible, I want to try to use my ruler here. So here is going to start right there. This is 8. There's 10, there's 12, and there is 14. So my second vector is going to be like this. Oh, and by the way, a vector is an arrow. We always draw it as an arrow. So you'll never see me draw vectors as just simply lines. This is a line segment. This doesn't tell me anything about direction, or I guess it doesn't really specify well enough about direction. Because of course this line that I've drawn here, let me make a copy of it, and we'll paste one here. Of course, right in the middle, I don't want it there. Let's try this again. Let me go over somewhere else where it's not going to paste it right there in the middle. Right, how about this? This vector could be this way. And of course, that's very different than if that vector was this way. So it's very important as we're dealing with vectors that you do put the arrows on it, indicating to us the direction that that vector is actually going. All right, so here we go. And the resultant here is going to be drawn always from the start to the end. I'm going to pause the video here and get this ruler set up. All right, so here we are. We have our ruler set back up, and the resultant would be drawn from where I started to where I ended. I'm going to move the ruler just out of the way for just a second so I can finish drawing the vector. We're going to call this the resultant here. And a resultant must have, because the resultant itself is a vector, it must have the magnitude. Can't even spell that. Let me try that again. It's going to have a magnitude, and it's going to have a direction in order to be completely defined as a vector. So let's bring the ruler back up, and let's move the ruler so it makes it easy to measure this. How about we measure it right there? Keeping in mind that each line on here represented 1 meter. So let's take a look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I'm going to go with 15. So that's about 15 meters. And this, of course, is the magnitude part of the vector. And then the direction part is going to be the angle in here. And of course, my ruler happens to have a protractor on it as well. If you were to be doing this kind of with your tools, you'd probably have a protractor in your hand. This would be, whoop, I can't draw without the ruler there. So that was going to be this angle right in here. That's going to be a 20-degree angle. And so to define this direction, I would say it's at a direction of 20 degrees to the south of east. Okay, another way to say this, or, and again, this is in another video, or bearing, this would be 90 degrees plus an additional 20, that would be 110 degrees if we're using the bearing type definition for direction. Okay, so once again, as I add these together, I've done this is to scale as close to possible. I would be using a ruler, making sure I've drawn these things to scale. I'm using the protractors to make sure that the angles are done properly. I then, of course, measure this with my ruler and use a protractor to measure my angles in here to give me the direction of my resultant vector. The resultant vector is, of course, a vector, so therefore it must contain both a magnitude and a direction.